Hello. In an earlier video I showed how in MetaTrader 4 you can simulate the OnTrade event. OnTrade is an event that's been introduced in MetaTrader 5 and it fires every time any kind of change or new trade or a trade close happens. And I showed how you can simulate that in MetaTrader 4. The OnTrade event doesn't tell you anything about what the change was that triggered the event, and the same is for MetaTrader 5 and the simulation in MetaTrader 4. And at the time I said that it is possible to update the MetaTrader 4 simulation to give more information about that change. So today's video is about showing those changes so that you can get details about which trades have changed and what changed in those trades. This is going to be based on the Tradeobserver class that I wrote in the earlier video, and I'll put a link in the description for that earlier video if you haven't already seen it, because I'm not going to be going over how that class works in any detail. This video would simply be too long if I went over that again. So all I'll be looking at today are the changes that I'm making and the new code to get the details about those trades. I'm starting with the Tradeobserver.mqh file, and that's the Tradeobserver class that was created in the earlier video. And there are only two small changes in here. The first change is to start scan, because I actually have to replace start scan in the new version because the scanning for detail from the changed trades is quite different to the scanning when I'm simply looking to see if something has changed. So I need to make that virtual, and then I can override it in a child class. And the other change is here, where I've already captured all the detail of the trades in the fill function. I'm not overriding that fill function. I'm just making a small change here, and this is not necessary, but sometimes there are no trades in the array, and array sort simply throws a warning message on the logs. So to avoid that warning message in the logs, and it's not a harmful message, that's why it was working before, but I'm just going to eliminate the warning message by only sorting if there is data in the trades. So to do that, I'm simply checking if the count of data is greater than 0, then I'll sort the trades, and if not, there's no need to sort. And those are the only two changes needed for the Tradeobserver class. Now for today, I've created a new MQH file, Tradeobserver V2. I've placed that in the same folder underneath Orchard Observers, same folder as Tradeobserver.mqh, because I'm going to be inheriting from Tradeobserver class. And I've already added the include statement here, #include Tradeobserver.mqh. So that will bring in the Tradeobserver.mqh file and allow me to inherit from Tradeobserver. The first thing I'm going to create is an enum that will simply list all of the types of changes that I'm looking for. Now, as this comment says, these enums are in the same order as the columns that are going to appear in the change, and these are the same order as I'm already capturing the current and historical information that I'm using to do the comparison. But then there are two types of changes that don't have column numbers, new and closed, which simply say either something new has been created or something that was there is no longer there. So these are additional enums, but the rest of these will correspond to column numbers in the array of trades. And the next thing I'm going to create is a structure that I can use to hold the changes. And I want to store the type of change that's happened, which will be the enum here. I want to store the old values and the new values from the trade. So in the structure I have the change type, and then I have two arrays which hold the current data and the previous data. And these are defined in the same way as they were for the original Tradeobserver class. I'm using the order last enum, which tells me how many elements are going to be in that array. And again, if you haven't seen the earlier video, see that and it will explain how that works. And now the class statement. I'm just calling the new class Tradeobserver V2, and I'm inheriting with the colon from Tradeobserver, and that's a public inheritance. So all of the public functions available in Tradeobserver will now also be available in Tradeobserver V2. In the protected space, I'm going to create a variable to hold the changes and a function that I'm going to use just to add changes to that array. So the array is using the structure SChange line, and it's just a simple array, and I'm just calling it mchanges. And the function I'm going to use to add lines or add rows to that array is called addChange, and that just takes the three elements that will be inserted into that array. So the type, the current data, and the previous trade data. The constructor here just shows that I'm taking the same arguments as the original Tradeobserver class. It's just the event handler, and I'm simply calling the constructor on Tradeobserver, passing that handler. So there's no further work to be done in the constructor in the v2 class. So that's just the open and close brackets. And the destructor also has nothing to do, so just open and close brackets there as well. There's one more function that I should have put into protected. I forgot about that, so let me just add that now. And that's the line copy function. I'm going to need this because the elements in the array of current trades and previous trades are a two-dimensional array, but I need to convert that to a single-dimensional array. So the line copy function will fill up this line single-dimension array with elements from the two-dimensional trades array using pointer as the initial index into that trades array. So you'll see that function when we use it. But that's necessary simply to convert the two-dimensional into a single-dimensional array. And then I just have two public functions. So the start scan is here because this is almost completely rewritten from the start scan in the Tradeobserver.mqh. It's very different. And then get changes, which will simply return a copy of the mchange array. Where is it? A copy of this mchanges array. And that takes a by reference argument of changes, which then gets populated and returned from this function. So I'll begin with the start scan function. It does call some of these other functions, we'll see them later, but start scan is where most of the work happens. So I'll start with that. So the syntax is simple. Void Tradeobserver v2 : start scan. That's the way to name any function in a class. It takes no arguments. The first three lines here, Tradeobserver data, or defining a current data array, which is of type Tradeobserver data, and calling the fill function, which is in the Tradeobserver v1 class, and then setting the Boolean changed value to false. They are identical to the earlier start scan in Tradeobserver, but that's where the similarities end. So the first thing I need to do is clear the array of changes, and I'm just using array resize. By setting the size of that array of changes to 0, that just removes any data that may have been in there already. And now I need some working values here. Now I'm comparing two different arrays, and they are in order, but each array may have additional data to the other array, so they're not necessarily the same size. So I can't use a single pointer that points at both arrays, so I'm declaring a pointer for the current array and the previous array, and I'm just initializing those to 0 here. And then to hold the data from each of those arrays when I find a change, remember I'm having to transfer the two-dimensional array of data to a single-dimensional line array, I'm defining those two line arrays here so they're ready to use when I get to a point where I need to copy data into them. And the size of these is order_last, which if you've seen the earlier video, you'll know that that is the last piece of data that I'm copying from each of these arrays. So that order last has been set to define the number of elements that I have to copy. In version 1, I could simply use a for loop and go through all of the lines of the array because I was just looking for any change at all. Now, because I'm looking for the detail of the changes, I actually have to make sure I go through both arrays, and so I've replaced the for loop with a while, and the conditions on the while are that the current pointer is less than the current data.count, so I'm going through everything in the current data array, and the same for previous pointer being less than mprevious data.count. So I'm going through everything in both arrays. So the first test I'm going to do is when something has been added, which is basically a new trade. And in that case, there will be an element in the current array that doesn't match anything in the previous array. Now, typically, this should be at the end of the array because new trade numbers are always greater than old trade numbers. But just in case that doesn't happen, I'm also going to test whether the trade number that I'm at with current pointer matches the trade number for previous pointer. So the test that I have here, if previous pointer is greater than or equal to previous data.count, that means I've run out of previous trades, therefore I must have a new trade in the current data. And remember, I'm running until current data is, or I'm running at while current pointer is less than data count and while previous pointer is less than count. So I'll keep going as long as there is something in either of these arrays. So if I've run out of previous data, then I must have a new element, or I'll also have a new element if, and then I have current pointer is less than current data.count. I need that to avoid an array out of range error. But I'm actually looking to say that current data.trade's current pointer order ticket, so the ticket number that I'm pointing at in the current data array, is less than previous data.trade's previous pointer order ticket. Now, because these arrays are in order, if I'm pointing at a place in both where the true trade numbers are different, then I must have something new, or I must have either something new or missing. And because I'm saying less than, that means that I've moved past the current ticket in the previous data, and I've got a ticket in current data that is new. So that's my test for new. And then I need to make a copy of that data, as I've mentioned several times. So I call the line copy function using the current line, and this is what will be populated in the line copy function. And I'm passing in current data.trades and current pointer, so I know which row of the current data trades to copy. And we'll see the line copy function soon. Once I've done that, I have current line populated, and I'm just going to call add change, which will add something to the mchanges array. And this is a change type new. And I'm passing that current line from here, and I'm passing the current line twice. So the add change takes both the current and the previous values, but I'm saying this is a new element, therefore there is no previous value, so I'm just passing the current line twice to that. And then I set the changed flag, so this is the overall changed flag that I define here, bool changed equals false to begin with. I'm just setting that to true, so that at the end of the function I can return and say yes, something has changed. And then only increment the current pointer. So I've said that either the previous pointer is already past the end of the array, or I found something in the current array that is earlier or a lower ticket number than the previous array, so I really only need to move the current pointer forward by 1. So current pointer ++, and that way the previous pointer stays where it is, ready for the next comparison. Now, after that test, the next thing I have to look for is something being deleted, and that could be either a pending trade deleted or an active trade closed. I'll just wrap this around so it's a little easier to see. So first test in here is the same, current pointer greater than current data.count, or at least similar, but here I'm testing it against the current data. So I'm saying if I've run out of current data but I still have some previous data, then the trade that I'm looking at in previous data must have been closed or deleted. Or, and this matches up with this statement here for the new trades, or the previous data is less, the ticket number that I'm looking at in previous data is less than the ticket number that I'm looking at in current data, then that means that the previous data ticket has been closed. And this is more likely. As I mentioned, this situation of having a new ticket number inserted that's new is very unlikely, because ticket numbers are typically always greater than already issued tickets. But this situation where an existing ticket number has been closed is very common, because you're closing an old ticket. So it's the same test. I've just reversed the previous data and the current data. And I'm saying that if the previous data ticket is less than the current data ticket, then that previous data ticket doesn't exist in the current data, therefore it must be closed. And then the statements here are the same. Line copy, but here I'm just using previous line and previous data. Add change, but here I'm using change type closed, and I'm passing the previous line twice, because obviously it doesn't exist in the current data, so I'm just using that previous line twice. And I'll mention now, when you get the results back of saying that something is closed, you'll see the previous line, but that won't include details of the actual closed trade. So things like the close time will not show correctly, because this is showing the data that we knew about the trade before it was closed. You can easily get that information just by going looking at history, but because I'm only looking at current trades when I populate the current data and the previous data, I don't have the history trades. And to get the latest information on a closed trade, you will have to do an auto select on history. But then again, just set change to true, and here I increment the previous pointer and not the current pointer. And then the last situation is where the ticket number matches, but some information on that ticket has changed. Here I'm going to look at each column of that data. So I know that the two ticket numbers match, so I'm looking at the same ticket. I now need to compare each element of data. So I'm using a simple for loop for int j equals 0, and this is similar to the for loop that was in the Tradeobserver 1 class, but I have to do a little bit more work here. Order limit is the last column that I'm going to check. So there is some data in a trade that changes constantly, like the profit changes constantly as the current price moves up and down. And the close price also changes as the current price moves up and down. But there's no point in comparing that. It's simply saying that current market price has moved. So I don't bother to compare those, and order limit has been set to the last column of data that I want to monitor. So this is a simple for loop. For j equals 0, j is less than or equal to the order limit, and j++. I've introduced a new Boolean value called line changed, because when I perform that line copy, I only need to do it once for this line. Doesn't matter what has changed. I'm not going to do the line copy straight away. I'm only going to do it when it's needed to save resources. And I'm going to use line change to tell me whether it's already happened for this line. So then the simple test, if current data.trades, current pointer, this is the row number in the current data, and j being the column number. And if that's not equal to the same column from the previous data, then whatever that column is, it has changed. And here, if not line change, so this is the first time that I've found a column that is different, then I'm going to copy both lines, line copy function for the current line and the previous line, and then I add that change, and we'll get to this in a moment, but now I'm passing actually the current line and the previous line, so I get both of those stored in the change array. I'm using this cast to enum change type of column j. So j is just an integer. I'm going from 0 up to order limit, and I'm casting that to the enum change type, and I'm scrolling back up to the top of the code, back to this enum change type that I declared. And remember, I said that these have to be in the same order as the columns. So if I get a change at column number 2, then that's 0, 1, 2, and that would tell me that the commission has changed. So that's why these enums are in the same order as the columns in the array of data. Back down here. So yes, add change, enum change type j, current line, previous line, set changed equals true, that's the overall change value. And after all of that, because these are matching trades, I'm going to increment both the current and the previous pointer. So these will continue to be incremented at all of these possible conditions until we reach the point where both the current and the previous pointer have passed the end of their arrays, and that's the end of that while loop. So after we reach the end of the while loop, there's not much more to do except to save the current data into previous, ready for the next comparison, and then if there has been a change, to call the event handler. So mPrevious data equals current data. That simply takes a copy of the current data and saves it ready for next time. And then if changed, if that overall variable indicates that we've had some sort of change, calling mHandler calls the event handler that was passed into the constructor of this class. Now there is something that I missed here. I'm just going to go back and fix that. I went to all the trouble to declare this line changed and even to test it, but I have to set it after I called the line copy. So I just set that to true at this point, and that way the next time we come through here, the line has already been copied. I don't need to make a new copy of current and previous line. and that's important in cases where there might be more than one column that has changed. It's just a performance issue. If I hadn't done that, then I would simply be executing the line copy every time, and the number of cases where you get multiple changes on a single line are few, so it wouldn't be a big impact, but I'm just trying to save a little bit of performance here by only making a copy of these lines once. So set that line change to true, and then this statement or these statements won't be executed again until the next line. So now the add change function. It's a relatively simple function. The type, current data, previous data, as I've said. I'm first getting the count of the array size of changes. I'm resizing that array with the array resize to count +1, so I'm just adding one extra row. And this (10) asks the system to reserve 10 rows, so that next time I do this, it doesn't go to as much work in adding an extra row. The space is already there, and it can simply allocate one more row out of that space, and it will do that until it's exhausted this 10, and then go again. Typically though, I would need 1, 2, maybe 3 rows. So this should be sufficient to make sure that I'm saving resources. And then I'm simply assigning mChangesCount.changeType equals the type passed in, and then I'm using the array copy into mChangesCount.currentData of the current array that was passed in, and then the same for the previous data. So I'm just copying those into the arrays in that structure. Now all of that data gets stored in mChanges. If you want to use that in your application to see what has changed, you'll need a copy of the mChanges array. So I have the getChanges function. So the return type of this is void, but the argument here, &changes, that's by reference. So what I'll be doing is populating the values in this. So the idea is that you create this array before you call this function, and then after the function's been called, that array has been populated with data. And that's an array of type schangeLine, which is the structure that we set up at the beginning of this code. And I'm just using a simple array copy and populating changes from mChanges. So the syntax for array copy is array copy into array from array, and then return. And finally that line copy function to transfer the data from the 2-dimensional array to a 1-dimensional array. So it's also void because I'm populating arguments that are passed in by reference. So line copy, line is the target line that I'm going to populate, and trades is the 2-dimensional array of trade data, and pointer is the index into the first dimension of that trades array. And then it's a simple for loop for int I equals 0 as long as I is less than order last. So I'm assuming that this is only being used for arrays of the type that we've defined, and that the maximum size there is order underscore last, which again was mentioned in the earlier video. So I'm just doing a simple loop. Line I equals trades index pointer index I, and that's all for the line copy function. And so that completes Tradeobserver v2, which inherits from Tradeobserver v1, or just Tradeobserver, and that gives all the functions necessary to store and retrieve the detail about what has changed. Now, the reason you may not want to do this, you may want to use v1 in preference. You've seen that this has to go through every line and look at every column of every trade to compare and determine if there has been a change. Version 1 simply looped through until it found anything that had changed and could exit very quickly then. So this will take longer to execute than version 1, simply because it isn't just looking for the first change, it must look for every change in order to be able to store those. I'll just do a quick compile to make sure I don't have a syntax error here. And that passed. And now I'm going to create an expert advisor just to demonstrate this, and the expert advisor will just create and delete and change some trades. So here I've already written the expert to demonstrate this because it's very simple. I'm just calling this OnTrade test v2, standard property statements. I've included Orchard Observer's Tradeobserver v2 because this is testing the Tradeobserver v2 class. I'm declaring a variable, Tradeobserver v2. It's a pointer to the Tradeobserver v2, and I'm just calling the variable observer. I've created 3 other variables: bar count, buy ticket, and sell ticket. So bar count I'm going to be using to tell how many bars I am into the expert, simply because it's just a demonstration expert and I'm triggering certain events based on which bar I'm up to. And then the buy ticket and the sell ticket will be used to store the ticket numbers that I get when I execute buy and sell trades. And the first thing, I'm just creating a new observer. So observer equals new Tradeobserver v2, passing in the OnTrade event. And this is also explained in the earlier video. And then return init succeeded. On dinit, I just need to delete the observer class. In onTick, I'm calling observer.startScan, and this is the way that I'm asking the observer to look for changes. Now, onTick is not as accurate as the function in MetaTrader 5 that returns the results from the OnTrade, because in MetaTrader 5 it happens as soon as a trade event happens. Here in MetaTrader 4, we have to wait for something else to trigger us to call this start scan, which means that it's possible to place a trade and then have to wait a few seconds until the next tick event happens before you find that trade. You can also speed this up possibly by using a timer, or even slow it down if you don't necessarily want to test on every tick. But at the moment I'm just calling this onTick. I'm calling the new bar function, and I'll just scroll down and show that before we go further. It's a standard new bar that just tells me if the current time for the current bar has changed, and if it hasn't, then it returns false to say this is not a new bar. If it has, then I'm resetting, but I've added in here gbar count ++, and that's what I'm using to count how many bars have expired, or how many bars have been created since I started running the expert. And that's because I'm using this gbar count in a switch statement, and I'm executing certain events based on the bar number. And I've just chosen bars number 2, 4, 6, 8, and so on. So at bar number 2, or at the beginning of bar number 2, I'll open a buy ticket. At the beginning of bar number 4, I will open a sell ticket. At the beginning of bar number 6, I will modify the buy ticket to add a take profit and stop loss. At bar number 8, I will close the buy ticket, so order select and then order close. At the beginning of bar 10, I'll close the sell ticket. And at the beginning of bar number 12, I'm going to create a buy stop and a sell stop, and then we'll be able to just watch the expert run until one of those is triggered. And then in the OnTrade event, so this is the event handler for OnTrade, first I need to declare that variable changes. Then I can call observer.getChanges and populate that. And then I'm just saying for each of the rows in this changes array, and I need to handle new and close differently because there is no column that matches the change that happens when it's a new or a closed. So I'm using the print format here. For a new trade and for a closed trade, I'm showing the function signature, then the enum of the event, which would be new or closed, the type, and this is the type of the trade, whether it's a buy or a sell or a buy stop or sell stop, the ticket number, and then for new and closed I have at, and this will be the price where the trade was opened or closed. For other type of events, I actually want to show the old and the new value. So I still have the function signature, the event type, the type of the trade, buy, sell, and so on, ticket number, but then I've got changed from %F to %F, and I'm simply filling in for these %F and %F the previous data value for that change and the current data value for the change. So I'll compile that. I'm getting some warnings because I'm not bothering to check the order modify and order select. This is only an expert to demonstrate what will happen. So now I'll change over to MetaTrader 4 and run the expert so you can see these things happening. Now I've started the expert, I'll just let it run to the first event. So the first event, and I can see a buy trade has been created here on screen. If I look at the results tab, I can see there a buy trade. If I go to the journal, here's the message inserted by MetaTrader. OnTrade test open ticket number 1, buy at 1.18517, and here's the event that I've captured. Change type new, so it's a new trade. Type is an order type buy, ticket number 1 at 1.18517. I'll let that run through now to the next event, which will be the sell trade. Now the sell trade's been triggered. If I go to results, I can see there's now a sell trade. To the journal, the system has inserted this open ticket number 2, sell 0.01, 1.18444. Here's the event that I've captured, change type new, new trade, of an order type sell, ticket number 2, 1.18444. Let that run through to the next event. So at this point, I know the next event has happened because we're 2 bars on. If I look at results, I can see I'm modifying ticket number 1. I've added a stop loss and a take profit. The take profit is well off the screen. The stop loss is also off the screen, but there they are, 1.18 and 1.23. If I go to the journal, here's the modify statement inserted by MetaTrader. I've modified the stop loss and the take profit, and the reason I'm doing this is that I can show you that there are now 2 events that I've captured. One is for the change in stop loss and the other for the change in take profit. So they're both identifying ticket number 1. They're both changing from 0, because nothing was set initially, to 1.18017, which matches the 1.18017 for the stop loss, and the take profit to 1.23517 here. So I've picked up both of those events. The next event should be a close. So now the buy trade is closed. We can see it's no longer here. It closed down here. If I look at the results, I can see a close for the buy trade on ticket number 1. If I go to the journal, here's the system inserted event for the close, and I pick up change type closed of a buy trade, ticket number 1, 1.18419. So that's the price here where the close was executed. Go to the next, which should be a close of the sell. So now the sell trade is closed. And in the journal, here's the system event, and here's the event that I've captured. Change type closed, order type sell, ticket number 2, 1.18461, and that's this price where the trade closed. What's left now is to see it opening the buy stop and sell stop, and then to see one of those being executed when the price hits that. Right, now we've got both a sell stop here and a buy stop here that have been opened. I can see the 2 system events, and here are my detected events, change type new on both, buy stop, sell stop, tickets 3 and 4, and the prices where they've been set to open. So now I'll just let it run until one of those executes. Alright, the sell has just converted from a sell stop to a sell. So now if I look at the journal, I will see system event says order number 4, sell was opened, and I have 2 events that I've picked up in the OnTrade. The first is a change in open time, because the original open time here at 16152558, that was the time that I placed the sell stop. The new time is the time that that sell stop converted to a sell trade. And I also have this event, order type sell, ticket number 4 changed from 5. All of these values stored in the array are just numbers, doubles in fact. 5 is the number that corresponds to a sell stop, and 1 is the number that corresponds to a sell. And they match up to the enums, enum sell stop and enum sell. So that's all there is to demonstrate. This is picking up all of the events that happen. It does wait for a tick to happen, but you can see that I'm now getting detail about the events that have happened. And if I want to know something about closed trades, I can always interrogate history for the ticket number that's been supplied. Next week, I have an update again on an earlier video on protecting code, because I've had a number of questions on that, and specifically around how can you reissue licenses, because in the original, the license was embedded in the code. And I've had some questions about how you can reissue those licenses without having to recreate the code. So I can show you how to do that next week. If you found this video useful, then please click the like button. That does help us a lot. If you want to see the code or download the code that I've used here, then it's available through our Discord channels. So if you see the description under the video, it will show you how to do that. If you want to see more of our videos, click subscribe and click the bell icon if you want to be notified when we do release those videos. So until the next time, thank you for watching.